What's up guys, and welcome to this tutorial on question 9 of the 2019 final physics exam. This question is on photons and electrons. Okay, so let's get straight into it. The longest wavelength that will cause an electron to be ejected from a sodium metal surface when light is shone on a metal is 583 nanometers. That's 583 times 10 to the minus 9 meters. Okay, so we start off with a definition. Okay, so define the threshold frequency. So the threshold frequency is the minimum frequency of incident radiation at which an electron, or at which electrons will be emitted from a particular metal. Okay, so we get 2 marks for that definition, and question 9.2 is calculate the threshold frequency. Okay, so we've already been given some information, so we can use that information. So we can say that C is equal to F times lambda, where C is our speed of light. So we have 3 times 10 to the 8 is equal to our threshold frequency times our lambda, which is our wavelength, which is 583 times 10 to the minus 9. And we can solve for our threshold frequency, so F0 is equal to 5,15 times 10 to the 14 hertz. Okay, and then it says hence calculate the work function of sodium. Okay, so the work function is equal to H times our threshold frequency. So H is our Planck's constant, which is equal to 6,6 times 10 to the minus 34 times the frequency we just calculated, which is 5.15 times 10 to the 14. And if we crunch those numbers, we get a value of 3,40 times 10 to the minus 19 with units of joules. Okay. Then it says a low intensity light of a wavelength 450 nanometers is incident on sodium. Okay, so on the sodium that we've been calculating before, calculate the kinetic energy of the ejected electrons. Okay, so we want the kinetic energy. So basically we can use the equation Hc over lambda is equal to our work function plus our kinetic energy maximum. Okay, so we know H is our Planck's constant, which is 6,6 times 10 to the minus 34. C is our speed of light, which is 3 times 10 to the 8, over lambda, which is our 450 times 10 to the minus 9, is equal to our work function that we already calculated there, 3,4 times 10 to the minus 19, plus our Ek max. And so we can calculate our Ek max. Ek max is equal to 1,00 times 10 to the minus 19 units of joules. Okay. And we get 4 marks for that. Then it says a high intensity light, also of 450 nanometers, replaces the low intensity. Okay, so the question goes, question 5.9.51, what are the effects of the high intensity light have on the kinetic energy? Okay, so remember, intensity is the number of electrons emitted, basically. So it has no effect on the kinetic energy. And so therefore high intensity has no effect. Okay, and 9.5.2, the number of electrons ejected. Okay, so it will increase because the number, our intensity has increases, so the number of electrons that are emitted will be increased. So increase, we can say there will be an increase in the number of ejected electrons. Okay, so basically there's no effect on the kinetic energy, and the number of electrons that are ejected will increase. Okay, and we get 16 marks for that. So nice, simple question, nothing too difficult there. Yeah, so thanks for watching, guys, and I hope you guys found this useful.